Can you see that in the classroom? Looks like this. You can't edit this. This is a PDF, so you need to just on a piece of paper somewhere do it. All the math I'd like to do by Friday. I'd like to take the test tomorrow and go over the test Friday. I think that's how I have it planned. Again, if you can do this, no problem. You'll be fine on the test. The test is very similar questions. It's just in a different format, so you can edit and things like that. I can put my face up. Can we do it on a doc? The test you can. This you can do on a piece of paper. You're not turning to me, or you can do it on a doc. I don't care. You're not turning this into me. I just want you to do it. And therefore, if you don't understand something, you don't understand directions, not sure if your answers are making sense to you, you're not sure if they're right, you can ask questions about it today. In about, I don't know, maybe 10 minutes, I'm just going to start going over this whole thing and start with question 1. Did you have any questions on it, Sarah? Your test is going to be very similar. It's just going to look different. It's the only way to make a ratio have a certain denominator, using graphing to multiply the numerator and denominator by something, then draw the line. Now you can take anyone. For example, number 1 on this page, 1 is 2/7. I want that to have a denominator of 21. 2/7 equals a denominator of 21. I could say, hey, I want to know what 2/7 is with a denominator of 22. It's just going to be a decimal. It's done the same way. But you can graph it, sure. I mean, graphing it is one solution to it. Oh, took everything off. Do we show you the work? Not for today. Today I'm taking your word for it. I'm not going to be grading this or anything. It is your time to practice to make sure you're ready for tomorrow. If you understood everything on this page, you should be fine for tomorrow. Again, it's going to be very similar questions, only in a different format that you can actually edit. This is just a PDF I stole from the book site. So if you can do these things, then you should be fine. You need 2 equivalent ratios to make a graph. To make an accurate one, yes, because remember, proportional relationships are lines. Are linear. So they are lines. And in order to graph a line, you need one of 2 things. 1, you either need 2 points, or 2, you can have 1 point and the slope of the line, or how steep the line is. This is steepness. Which, if you really want to get into slope, slope is also equal to rise over run, which is rise is your y value over your x value. So there's a ratio right there. So slope in itself is the other ratio if you want to do it that way. But we looked at it this way, 2 points. So if you're making a graph, if you're on the table question there, number 10, if you're looking at number 10 here, and actually it's number 12, but it deals with number 10. Number 12 is the one that it's asking for. Looking at that table, so you have a table here, and you have weight in pounds here, And you have cost here in money, and 1 to 425, 2 to 850, and so on, right? These here are your points, right? So this can be your y point, this can be your x point. Might be easier that way. Put cost on the bottom. And then again, that's slope, rise over run. We do number 13. Yeah, I figured we'd have questions on 13. 13 is just one of those badly worded questions. And I'm just going to get rid of all of it. "13 is a strange question." First, just reading it, trying to figure out what it is saying is just kind of hard. But if you look at it, and let's see if I can copy it. PDFs don't like you copying things all the time. And so here's 13. Okay, so Marlburg, in Marlburg, whatever, wherever this place is, a ratio of 1 to 2 yes votes to a total votes passes a proposal. So here we have a ratio of 1 yes out of 2 total, and this equals a pass. That's what it's saying. So if 2 people vote, 1 says yes, it's passed. If 2 people vote and less than 1 say yes, it doesn't pass. In this case, we're looking at, they want to increase this ratio, but no less than 1 to 3rd. So they want, this is not working for them, so they want to change this ratio, but they don't want to change it so much that it's going to get to this, which is yes in total. So here it's saying that 1 vote out of 2 is going to pass something. Here it's saying 1 vote out of 3 is going to pass something. They think this is too hard to pass or something. I don't know why they want to change this, because this is like, hey, if half of them say yes, then it goes. This is, if 1/3 of them say yes, it goes. They want a ratio that's between these two, is what they're asking for. And there are many different ratios to choose from. So they're trying to get a little open-ended here, but they want a number that is between 1/2 and 1/3. So they want a ratio, so they want an x value that is larger, or I'm sorry, oh yeah, I guess we could do larger than 1/3, but less than 1/2. So again, if you're thinking kind of fractions in your head, that would be a half. That would be 1/3. They want something in between these. So in between 1/2 and 1/3. And like I've mentioned before in class, any two numbers you give me, you can find a number between. So one way to look at this is to turn these into decimals. You can find the unit rate for each of them. So turn these into decimals. 1/2 is equal to 0.5, and 1/3 is equal to 0.6 repeating. And you want a number between 0.6 repeating and 0.5, which might be hard for some to get. But if I were to rewrite these numbers and take it to one more decimal place, it might be easier. So you could have 0.66 repeating and 0.50. And you want a number between 0.66 and 0.5, which you can get a whole bunch of different numbers really if you wanted to. So between 66 and 50, pick a number, right? 0. I don't know, I think 40 could work. So if you have a unit rate of 40 here, however, that's going to be So what, I mean, if you want to make that as a ratio, that would be 4 out of 10, right, which is 2/5. So out of 5 people, two people need to say yes in order for it to pass. 1/3 is not repeating, so you're right, it's not, sorry. 1/3 is repeating 3. The 40 still works because my mind was thinking repeating 3. But anyways, so thank you for that. But yeah, you have a number between the two. So this here is a ratio that'll work. This here would be the unit rate for it. And then you explain why it works is because this fraction, 2/5, fits this criteria. 2/5 is greater than 1/3, but less than 1/2. So there's your explanation. The other way that you can do this is by looking at common denominators. So let's get rid of all our decimal stuff and keep things as fractions. And you can look at this as common denominators. You want to compare, you want a number between 1/3 and 1/2. So let's find common denominators and see what happens. The first common denominator you're probably thinking of is 6. However, 6 really isn't going to work too well here. But if I rewrite these with a common denominator of 6, this will be times 2 times 2. This becomes 2/6. Over here, this is times 3 times 3. This becomes 3/6. And then if I asked you, can you pick a number between 2/6 and 3/6? You're probably at a loss unless you go with like 2.56, which is a frowned upon fraction. So don't do that. But you could take the 2.56 and just inflate it, multiply it to get rid of that decimal. So you could multiply each by 2, which will do it. Or you could just start back over here, and instead of picking a denominator of 6, so I erase everything. You can pick a denominator of 12, because that's also a common denominator. In doing so, this will be multiplied by 6, this will be multiplied by 6, that gives you 6, this will be multiplied by 4, this will be multiplied by 4, that gives you 4. And then if I ask you to pick a number between 4/12 and 6/12, you should see very easily that 5/12 fits right in between. In that case, 5/12 can be your ratio if you want to use it. Again, there's an infinite amount of numbers between 1/3 and 1/2, so you could pick as many as you wanted. Just pick your ratio, then write it as a decimal, which is the unit rate. So 5 divided by 12, I think, gives you 0.4. 5 divided by 12, 1/6 repeating. Whatever your unit rate for that is. This here would be your unit rate, so this would be yes votes to votes, right? So you need 0.4 yes votes for every vote in order for something to pass, which is less than a half, which is what you want. You want a number less than a half, but it's also greater than 1/3, and that's what you want, a number greater than 1/3. So any way you look at it, there's many different answers for it. It's kind of open-ended. And it is kind of strange because who wants less than a half yes votes to pass something? If most people don't want it going on, then don't do it. But that's how Marlberg is working. So hopefully that cleared up 13. Is Chapter 10 review due by the end of the day or tomorrow? Logan, I'm not collecting it, so hopefully you get it done. So that's the answer. There's many answers, Catherine. Again, as long as you pick a number that's between 1/3 and 1/2, that's a correct answer. Here I picked 5/12, right? Because you have to find a number between those, and then it asks for the unit rate as a decimal, which is right here, and then it asks for an explanation on what this actually means, and this means for every vote, 0.16 repeating has to be yes for it to pass if you use the ratio 5 to 12. Yeah, Kelsey, I was planning on going over all of them, but I was giving you guys a chance to look at them because it is a review. But that's 13. I can probably do it again at the end if everyone's done. But if you guys have had time to do it, so I'm going to start going over them so you can check your answers as we go it. Again, Eli, you're not turning it into me, so you should practice writing in full sentences, but no one's going to see it except for you. No, Lyra, this is it for today. It's just practice, and I'm planning on giving you your test tomorrow. So stick around. We're going to go through the whole page here so you can check your work, and then if you don't miss anything, you're probably good for tomorrow. If you do miss something, look back in your book and on your notes on the topics that you missed, so you have some practice to do it for tomorrow. I do not plan on live streaming tomorrow because it's just you taking a test. So you should just take the test, and that's math class. It will unlock at 8 o'clock in the morning. You have all day to do it. In fact, you actually have until math class tomorrow to get it done. So you have over a day to do it if you really wanted to. So let's start and just go with number 1. So if you're still working, you can, but I'm going to go through number 1 right now. Yes, Sarah, the test is going to be online. We're going to try it. Do the best you can. If you have questions, bring them Friday. I'm gonna assume a lot of people have some questions about how to do the test or something didn't work out for them, and I will answer them on Friday. But I want to give you a chance to do it and see what you guys can come up with on your own. So that would be tomorrow. Number 1 says 2 to 7 is equal to something to 21, and you want to know what that is. So again, this is just finding equivalent fractions. You can set this up as 2/7 equals something over 21. This is your unknown. Your unknown's here. More than welcome to cross multiply for that. However, you probably should realize that if I multiply 7 by 3, I get 21. So 2 times 3 should equal x, which is 6. So number 1, your answer should be 6. Number 2, you're looking at 5 over 6 is equal to something over 24. Again, rewrite them as fractions so you can do it. Again, you can use equivalent fractions here, or you could do the cross products. Doesn't matter, you're going to get the same answer. In this case, 6 times 4 gives you 24, so 5 times 4 should give you 20. So number 2, your answer should be 20. Number 3, we got 4/9 is equal to 20 over x. In this case, the 20 is on top because it's listed first. Pairs up with the 4. And again, you do 4 times 5 to give you 20, so 9 times 5 will equal x, and that gives you 45. So 3 should be 45. 8/12 equals 24 over your unknown. Again, write them as fractions. 8 times 3 gives you 24, so 12 times 3 will be 36. So number 4 should be 36. So there's your first set there. Hopefully you didn't have any questions on those. Those are pretty straightforward and simple. 5 and 6 asks you to find the unit rates. So unit rates, we have for 5, you have Evan runs 15 miles in 3 days. You probably want to know how many miles he runs per day, which makes sense compared to how many days he lives per mile he runs. Anyways, miles per day makes more sense, so I set it up that way. You just divide it. 15 divided by 3 equals 5, so he does 5 miles per day. Do not forget units. So number 5 is 5 miles per day. Let's see. Number 6 we have as 6 inches in 4 years, so she's growing 6 inches every 4 years. And again, this is just division. 6 divided by 4 will give you that. You might be able to do that in your head. If not, just keep in mind the when you do it like this, the numerator is what goes in the box. So it would be 6 divided by 4. 4 goes into 6 once, so that's 4 times, you get 2, so that's 2/4, which is equal to 1.5 or 1.5. So 6 is 1.5, and then again your units are coming out right here, inches per year. So don't forget your units with those things. Questions on 5 or 6? Doing good so far. Alright, so 7 is your best buy prices. So this is make things your unit price and then make them the best buy price. So find unit price. And then we want to find the best buy. So each one we're going to write as a fraction in order to get unit price, right? So they are all dealing with folders and money, so we're buying folders. We want to know how many folders we can get for every, I'm sorry, we want to know how much money it costs per folder. So we want money per folder here. So we're going to write all of our ratios in that format. So for A, we have money on top, which is 195. 195 for 3 folders. B, you have 816 for 12 folders. C, you have 315 for 5 folders. D, you have 2130 for 30 folders. Then you just divide out each of your ratios. So you can grab a calculator for these because you're going to get some decimals. But you're just doing division here. What is 195 divided by 3? 195 divided by 3, just watch your decimal points. You're getting 0.65. This here is your unit price. So these here will all be your unit prices. So this costs, what this means is every folder, if you want to buy one folder at this rate, it costs 65 cents. So over here we have 8.16 divided by 12. This is going to be 0.68 per folder. So right away, just comparing these two, it's cheaper for rate 1 or rate A because it costs less per folder. 0.65 is less money than 0.68. 65 cents is less than 68 cents per folder. So just keep going, divide it again, 3.15 divided by 5 gives you 0.63 per folder. So in this case, this one here is so far the cheapest, right? 63 cents is cheaper than 68 than 65. Last one, you do 21.30 divided by 30, and that equals 0.71 per folder. Right? So for 7, you actually got a bunch of answers because you're supposed to get the unit price for each of them. A equals 0.65 per folder. B equals 0.68 per folder. C equals 0.63 per folder. And D equals 0.71 per folder. And out of all these, which one is the best buy? C is the best buy. So that's 7. Number 8 and number 9 are pretty much like you did yesterday for your review yesterday. These are the problems that you'll probably end up using your cross products for, but you just set up the proportion for it. So you know that it's going to look like a fraction is equal to a fraction, and you just got to fill in your numerators and denominators. And as you read number 8, it says Gregory cuts 4 yards in 6 hours. So here we have 4 yards for 6 hours. So there's your first ratio, just goes right in. And how long will it take him to cut 10 yards? Well, 10 yards is yards, so that goes up there, and we want to know our unknown there. And then you can use your cross products to solve, or if you know the relationship between 4 times what equals 10, which some of you might know off the top of your head, and do that to 6, but we're going to do cross products because it's not too difficult here. 6 times 10 is going to be equal to 4 times x. 6 times 10 is 60 equals 4x. You're going to divide this by 4, you're going to divide this by 4, and you're going to get 60 divided by 4 is 15. So for number 8, your answer is 15 hours. And keep in mind your units. This is hours, so this here has to be hours as well. Yards are on top, hours are on the bottom. I'm getting close to my face. Number 9. Done the same way, only we have a different ratio. Here it says Parker reads 20 pages in 15 minutes. So you have 20 pages, 15 minutes. That is equal to how long it will take him to read 45 pages. So this was pages, and this was minutes. 45 is pages, so 45 is going on top. And we don't know x. So 15 times 45 and 20 times x. You might want to reduce this first. This is pretty easy to reduce to keep your math a little easier. So if you reduce 20 and 15, you get 4/3 is equal to 45 over x. Makes it a little easier. You can do 3 times 45 and then divide it by 4. 3 times 45 gives me 135 equals 4x, and then you're going to divide each by 4 to get x by itself. This cancels. 135 divided by 4 gives you 33.75, and that would be minutes. So number 9 is 33.75 minutes. And again, it's minutes because the bottom here is minutes. So that has to be minutes. Any questions so far? Hopefully we're not screwing these up too bad. Number 10. number 10, it gives you this table. For the next few, we're going to use this table, so I'm going to copy the table over here so you can see what's going on. For number 9, you got 59.27. You don't have to do unit rate for 8 and 9. I don't care how you do it. For number 9, let's look at number 9 real quick. Double check that I did that right. So 9 is 20 over 15. This is pages, this is minutes. And 45 is pages. And this is minutes. Did you set it up like that, Sarah? Make sure your pages are lined up. Make sure your minutes are lined up. Okay, and then you're going to do 15 times 45 is equal to 20x. 15 times 45, I don't know off the top of my head, gives me 675, and 20x. Divide by 20, divide by 20. Yeah, I'm still getting 33.75 as x. So just watch your units. I can see people making mistakes there. Line up your units for things. And note, Eli, you don't have to do unit rate. You can do it however you think is easiest. I'm not going to be too particular about it. But number 10, it does ask for a unit rate for number 10. So that's kind of small. So our table says we have pounds on top and dollars here. If we have 1, 2, 3, 4, 1 pound is 4.25, 2 pounds is 8.50, 3 pounds is 12.75, and 4 pounds is 17. So that's our table. The table shows the cost in dollars of buying a certain amount of almonds. Okay, cost of almonds. Cost of almonds per pound, I guess. So we have cost of almonds per pound. So what is the unit rates? So this is number 10, asks for the unit rates. The unit rate is, I want to know how much does 1 pound of almond cost? That's what it's asking you. That's like definition of unit rate. It's just saying like how much is 1 pound of almonds. Well, that you just read your table. It's right here. 1 pound equals 4.50. So it is, or 4.25 per pound. It's your unit rate. Comes right out of the table. Number 10 shouldn't be an issue for. Comes right out of the table. That's 4.25 per pound. All right, so that's number 10. Number 11 is, what do the numbers of the unit rate mean in context of the problem? So explain, number 11 is saying to explain what that means. And this means for 1 pound of almonds, it costs $4.25. So that would be 11. 11 is 1 pound of almonds is $4.25. Lastly, number 12 is just asking what points, if you were to graph this table, what points would you use? And it's pretty simple. Again, you're probably going to look at your unit rate for it. So you have your money first and your pound second. So just keep in mind we're probably going to use rise over run, which is what slope is, because this deals a lot with slope. You just don't know what slope is very well right now. So rise over run, which is y over x. So your first is going to be y, your second will be x in this case. So when you write those as points, x goes first and y goes second. There's 1 point. X goes first. X goes first and y goes second. And y goes second. And this is going to give you the graph that's money per pound. Or, I'm sorry, this is actually going to give you the graph that's pounds per money. You could also, I mean, it's going to depend on how you interpret it. Yeah, this is what Eli is saying. It's going to depend on how you interpret your graph. I mean, it depends on what you want to graph on what line. Do you want to put money down here and pounds over here? Or when you graph it, do you want to put money here and pounds here? And that's going to depend on what you're actually looking for. So you could switch these around if you needed. It's not that big of a deal when it comes to money in pounds, because you really don't know which one is considered your independent variable and which one's your dependent variable. I mean, the amount of pounds that you buy might be determined based off of how much money you have to spend, or you might spend so much money based on the fact that you need so many pounds. So it depends on your context. So you could graph it this way too. Just keep in mind what means what. And this is 1275 and this is 4. And again, this here is when you graph pounds per money, and this would be money per pounds. So I guess if we're going with how we did numbers 10 and 11, this here is a better option, but it depends on what you're really looking for. Like you draw a line with rise over run. Okay. We can graph some slope if you want. It's not going to be on your test, Eli. So you have your ratio is, we'll keep it simple, 1 over 2. And we're only going to stay in the first quadrant, but we can plot this as a point, right? You can plot 1 to 2, which you probably want to plot here. right? If you're going to do rise over run. So your point would be 2 comma 1. With that being said, this here is also your slope, or the steepness of it. So this is rise over run. So 1 is your rise, 2 is your run. So you're going to start at this point here, you're going to go up 1, and then you're going to go over 2, which puts your next point there. Now you have 2 points, and you can just connect your line. Or you can go in reverse to there. And then you can just keep going up 1, over 2. And you can get your other points from it. But if you look at it, your other points are what? 4 and 3. Is that one? I'm sorry, this would be 2. Right, so 4 and 2 would be your other point, which is an equivalent ratio. Let's try a different type. Let's look at something different. I'll try it again differently. We can look at a function. Equals 2x plus 1. So this is a function, okay? There are many different answers to this. This is your y value. So whatever you want to put in for x, you get something out for y. This is a line, right? It has every value you want in there. I can put in any value I want for x, and it will give you your y point. So you could sit there and you can say, hey, let's make an xy table and plug in 1 for x. What would y be? If x is 1, well, 2 times 1 plus 1 hopefully gives you 3, right? And then I can plug in another value. Let's make life easy and plug in 0. 0 times 2 plus 1 gives you 1. So now I have 2 points I can graph, and then I can graph that way. You can do it that way, or you can look at it as slope. And I'm not going to use this point because that took some math to find. This point was really easy to find, right? I just plugged in 0 here, and that canceled all my multiplication out and left me whatever number this is. So I know that's a good point. So that's a great place to start. So let's put that point on, which would be right here. Then because of the format of this is a line, this number here is your slope. So 2 equals your slope. And if you wrote 2 as a fraction, that would be 2 over 1, right? So then I'm going to start at this point here, and I'm going to go rise over run. And again, rise is y, run is x. So I'm going to go up 2. So 1, 2. I'm at the 3 point there. And I'm going to go over 1. So I'm at the 1 point there, so my point's going to be here, which is 3 comma 1, which is what we get if we plugged in, I'm sorry, 1 comma 3, which is what we get when we plugged in 1 for that. And then you got your 2 points, you can draw your line. Again, you don't need to know slope for the test. You can do it just by plotting 2 points. I will teach you, or whoever your math teacher is next year will teach you slope a little more in depth, and you'll hit it real hard in 8th grade with algebra. With that, if there's no more questions, test tomorrow. It's going to unlock at 8. I do not plan on having a live stream. Your job is to just get your test done. Submit it to me the best way you can. Hopefully you can just submit it right on the classroom, but if you're having issues with that, you can always email it to me and I can work it out from there. And then Friday we will go over the test to see if we have any questions. Yeah, Eli, it's okay if you don't get it right now. We will do it again some other year. You're not required to know it right now. So with that, any further questions, email me. Other than that, I hope to talk to you Friday, if not before. So thank you and goodbye.